All right, today we're going to talk about groundwater and surface water. So we're looking at our main question, how is groundwater and surface water interconnected? Our objective is 8.9A.7. We're going to explain the interconnected relationship between surface water and groundwater. So surface water is water on the surface of the planet, and we're looking at ponds and lakes, streams and rivers, wetlands, oceans. It's replenished by precipitation and groundwater, and more prone to pollution than groundwater. So surface water is all the things that we see around us. Now, groundwater is going to be that water that's found underground in cracks and spaces in soil, sand, and rock. It's stored in and moves slowly through aquifers. More than 50% of the people in the United States get their drinking water from groundwater. Largest use is irrigating crops. It's less prone to pollution. So our groundwater still can possibly have some pollution, but it's going to be less likely to be polluted compared to our surface water. Now, some supplies for today's activity. You're going to need copy paper, colored pencils, a pen, or a pencil. And this is the best way for you to understand the vocabulary that we're talking about with groundwater and surface water. So groundwater and surface water is not a hard concept to learn or to understand. What comes challenging is all of this extra vocabulary for all the different parts of the groundwater and our zone of variation and our zone of saturation. So to learn this, we are going to draw a picture. So let me show you this picture. All right, so now that you have your color pencils and your paper and a pen or a pencil, we're going to draw a very simple picture, okay? So you can see that I have a tree to demonstrate that this is the surface that we're talking about. And I have a rain cloud to show that it's raining. And then what happens with rain, okay? So rain, some of the rain is going to go into our surface water, which is going to be our waters, our rivers, our streams. And then some of it's going to soak into the ground as infiltration. All right. And so lots of stuff going on here. So I want you to take a minute and just draw the basics that you see here. So you want to draw a tree to show this is the surface. And then you want to draw the infiltration, your cloud with the rain, and draw the arrows to show that should represent that water that's flowing through the soil. You want to label the zone of variation, the water table, the zone of saturation. You want all these parts, okay? So I want you to take a few minutes, draw that, and then we're going to add a little bit of details to it. So your teacher may need to pause the video so that you have time to draw this. I would recommend pausing it to draw. All right, so some things that we're going to add. So just so that we understand this vocabulary and what's going on. So when we studied soil, we learned that permeable meant that it allowed the water to flow through it, that the pore spaces were large enough that the water can intertwine through the rock, okay, or flow through. So we're just going to remind ourselves some of these things, okay? So I'm going to add my text feature. And so with your pen or your pencil, you're going to add some information. Okay, so all right, so I can put my text box out here, and I'm going to remind myself that this is the section. Permeable rock or soil means that it's able for groundwater to flow freely. And I'm also going to say between rock layers. Okay, so we know that the groundwater can flow freely between rock layers. I'm just going to draw a little arrow to just remind myself that this goes with this. Okay, that's what that means. And then impermeable is not able to flow. And we're usually talking about, if you remember when we talked about this, we are talking about clay. So clay is an impermeable type of soil, okay, it does not allow the water to flow through. So when there's clay, the water is going to sit on top of it, okay? And now there are some pores in clay, but they're so teeny tiny, they're not connected. All right, so let's put my text box out here, okay? And so impermeable is going to be few or no connected pore spaces, which is clay, and the water sits on top, okay? That's what that means. And then, of course, I'll draw my marking to make sure that I know that that's connected. Okay. Now, our zone of saturation here, I mean, what do you think zone of saturation means? Okay, yeah, full of water, holding water. Well, remember when we talked about those pores, the spaces, so that when we have a zone of saturation, every single pore, every single space, every single hole is filled with water. So that is our zone of saturation. So our zone of saturation is going to be that region in the ground where every pore space is filled with water. Okay, and that is our, let me do a different color. Here we go. Our zone of saturation. Our zone of saturation. Region in the ground where every pore space is filled with water. And then our water table is going to be that upper zone. It's the upper section or the upper zone of saturation. And it's going to move. It's going to move up or down depending on how much rain we get. So how much rain, how much water goes through the soil, that water table is going to move up and down. And so the water table, when we have our rainy season, our water table is going to be really high. And then when we have a drought, it hasn't rained in a very long time, then that water table is going to move. This water table line will move down, okay? And so that means that our zone of aeration will become larger because our water table has moved during the drought, and our zone of saturation will become smaller. So water table, upper zone of zone saturation moves up or down depending on rain. All right, so our zone of aeration is the region between the Earth's surface and the water table. All right, and so infiltration, okay, and that's going to be the process. That's the process by which water on the ground surface enters the soil. So process. Okay, I'm going to draw my arrow to infiltration. All right, so it's very important that you understand every bit of this so that when you see your own visual, you know exactly what's going on here and you can explain it. So you should be able to explain these things. So let's see how much we remember. So what is the primary source of most surface water, such as rivers and lakes? What is our primary source? Oh, good, Carmela. Rainfall. Yes, Carmela is correct. It is rainfall. So the primary source of most of our surface water is rainfall. Now, if you live in our northern places, and you could talk about snow. I see Leland said snow is a possibility. Yes, snow also is a possibility. So rainfall or snow is the correct answer. And then why would gravity be a useful topic to include in a description of the movement of water? Why do y'all think that it would be important to include gravity when we're describing water or the movement of water? Ooh, good, Jameer. Yes. So water flows downhill, and it flows downhill due to gravity. All right, very good. So make sure that you are studying your map and you're able to describe it and explain it and create your own. And remember this information for when we start talking about watersheds. So we're going to be able to apply this to our watershed lesson.